This is notes 8-5 on solving equations with variables on each side and multi-step equations. We're going to solve equations with variables on each side, will be section 1, and then we're going to solve multi-step equations, which is section 2. The Common Core state standards are listed in the mathematical practices. So for section 1, we're solving equations with variables on each side. There's steps to follow. You're going to fill in the box. The first thing that you want to do is if you have any subtraction, you're going to change subtraction to add in the opposite to make it easier to solve. Then you're going to write an equation with a variable on one side, solve the two or one-step equation, and then check your solution. So we're going to solve the following equations algebraically by showing all steps, then check. So on the first problem over here, we have 3x is equal to x plus 8. Whenever you have a problem with unequal terms on each side, we have one term on the left and two on the right, you always want to get rid of the term that is not by itself. So we want to subtract x on both sides. We can also put a 1 in front of that x, so we're really subtracting 1x on both sides. So we're on the left, we have 2x is equal to, and the 1x minus x becomes 0, and we're left with 8. Now we're solving the one-step equation. So we're going to get the x by itself, so we're going to divide both sides by 2, so x is equal to 4. So to check the work on this problem, we're going to put x on the left and on the right. We're going to replace it with a 4. So it's 3 times 4 equals 4 plus 8. 3 times 4 is 12. And 4 plus 8 is equal to 12. So since both sides are equal to 12, 4 is the correct solution. Number 2, 7x is equal to 5x plus 8. 5x is not alone, so we're going to subtract 5x on both sides. So we're left with 2x is equal to 8. One-step equation, divide both sides by 2, and we're left with x is equal to 4. So if we substitute in our 4 on the left side, 7 times 4 is 28, equals 5 times 4, which is 20, plus 8 is 28. So both sides equal 28, so 4 is the correct solution. In number 3, we have 3x minus 2 is equal to x. So our term that's alone is the x, so we want to minus 3x from both sides. We can put a 1 in front of the x also. When we do 3x minus 3x, we bring down the subtract 2, which really now is a negative 2 because we can change that to adding the opposite. And then 1 plus a negative 3x gives you negative 2x. Divide both sides by negative 2. So on the right-hand side, you're left with x, because negative 2 divided by negative 2 gives you a 1. And on the left-hand side, negative 2 divided by negative 2 is 1. So x is equal to 1. Showing out your work, to check it, 3 times 1 is 3, minus 2 is 1. On the right-hand side, 1 times 1 is 1, so both sides are equal to 1, so 1 is your solution. Number 4 is 3x plus 2 is equal to 4x minus 1. We have variables on both sides. We have an equal amount of terms on both sides. So we can get rid of either the 3x or the 4x. I like to always get rid of the variables on the right-hand side. So my answers look like 1 and 2, where it says x equals. If I get rid of the 3x, I'm going to have my answer look like number 3, where it says 1 equals x. So I'm going to subtract 4x from both sides. I'm going to do a little changing to adding the opposite. On the right-hand side, because my 4x minus 4x gives me 0, I'm left with a negative 1. And on the left-hand side, because I have 3 minus 4x, I'm going to change it to 3 plus a negative 4x. I'm going to take the sign of the larger number and subtract, and I'm going to bring down my plus 2. Now I have a two-step equation. I still want to get the x by itself, so I'm going to subtract 2 from both sides. So I'm left with negative 1x. 2 minus 2 gives me 0. So I'm just left with my negative 1x on the left. And on the right-hand side, it says negative 1 minus 2, or I can change it to adding the opposite, so it's negative 1 plus a negative 2 to give me negative 3. Now I'm going to divide both sides by negative 1. Negative 1 divided by negative 1 is 1x, or just x, and negative 3 divided by negative 1 gives me a positive 3. Number 5 is 2 4/10 plus a is equal to 2 5/10 a minus 4 5/10. Since we're dealing with decimals and I need to get one of my variables to one side, I'm going to put a 1.0 in front of the a. Now I can subtract the 2 5/10 a from both sides. So I'm left with 2 4/10. And now I have 1.0 minus 2.5, or I can change it to adding the opposite. So I would take the sign of the larger and subtract to give me negative 1 5/10 a equals 2.5a minus 2.5a cancels out. We can also change the subtraction to adding the opposite. So we're left with negative 4 5/10 a. Now, we still need to get to the variable to one side, so we're going to subtract 2 4/10 from both sides. So the 2 4/10 cancels out, so you're left with negative 1.5a equals, and we're subtracting the 2 4/10 or adding a negative. So we have same sign, so we're going to keep the sign and add. And we need to get the a to one side, so divide both sides by the negative 1.5a. So on the left-hand side, it cancels out, and we're left with a equals a negative divided by a negative is positive, and 6.9 divided by 1.5 is 4.6. On number 6, we have 1/2 p minus 15 is equal to 3/4 p minus 3. We're going to deal with fractions, and we need to get the fractions to one side. And if you look at your denominators, you have a 2 and a 4. So let's change these so we can have common denominators. So I'm going to rewrite it. So my common denominators would be 4. So I'm going to change my first fraction to 2/4 p minus 15 is equal to 3/4 p minus 3. I can also change subtraction to adding the opposite. And now let's get rid of the 2/4. So subtract 2/4 on both sides. That's both sides of your equal sign. So now the 2/4 p's cancel out. And you're left with negative 15 is equal to 1/4 p plus a negative 3. Now we're going to add 3 to both sides. The 3's cancel out. Opposites cancel out, so now we're left with 1/4 p is equal to, and we have to take the sign of the larger and subtract. So we end up getting negative 12. Multiply both sides by 4 to get the p by itself. So the 4's cancel out, so you're left with p on the right. And on the left, you're left with 4 times a negative 12, which is negative 48. In the next problem, it's a real-world problem using variables on both sides. So it says a personal trainer charges a one-time fee of $60 plus $25 for each individual session. So if they're paying a one-time fee, that's just $60 plus, and then $25 for each. Each represents multiplication, and it says for each individual session. We don't know, so we'll call that X. A fitness club charges a yearly fee of $450 plus $10 for each session with a personal trainer. So now in this sentence, it charges a yearly fee of $450, so that's a one-time fee, plus $10 for each, so that's multiplication, session with a personal trainer. So that, we don't know how much that is, so we'll call that X. Write and solve an equation to determine for what number of sessions the cost will be equal. So we're going to set both sides equal to each other. 60 plus 25x, that's the personal trainer, equals to the fitness club, which is $450 plus $10 for each session. Now we want to get the variables to one side, so we can subtract 10x from both sides. $25x minus 10x gives you 15x equals 450. The 10x minus 10x cancels out. Subtract 60 on both sides. The 60s cancel out, so we're left with 15x is equal to 390. Divide both sides by 15. So x is equal to 26. So for the cost of each of them to be the same, it's when they do 26 sessions. By substituting in the 26, you can see that they're the same. 25 times 26 gives you 650. And this would be 60 plus 650 to give you 710. And when you substitute the 26 in for the x, that gives you 10 times 26, which is 260, plus your 450 to give you 710. So 26 sessions and they would pay the same amount. This is the vocabulary for Lesson 8.5, Section 2, which we have null set or an empty set. And that's a set with no elements shown by the symbol, the 0 with a line through it, or the brackets. This means an empty set, or null set. In our example, we have variables on both sides. We have to distribute. And when you go through all the steps to solve it, in the end, on the last step, when you combine like terms with the negative 5s and the positive 5s, it cancels out and you're left with a negative 14. Same thing on the right side. The 5s and the negative 5s cancel out and you're left with 6. Well, negative 14 does not equal a positive 6. So that means it's an empty set or null set. There's no solution, it does not work. Identity is an equation that is true for every value of the variable, or all numbers work. So in this equation with variables on both sides, going through all the steps with the distributing, combining like terms, when it gets down to the last step, we can subtract 3 from both sides. When you subtract 3 from both sides, you're left with a positive 10 on the left and a positive 10 on the right. Well, that means that no matter what you put in for your variables, the left side's always going to equal the right side. That means all numbers that you substitute in for the value of the variable will have the left side equal to the right side. So here's your notes for Section 2 on solving equations with grouping symbols. So fill in the box, pause as needed. These are the steps to follow. The first thing we're going to do is add the opposite to make it easier to solve. Distribute if we have any parentheses. Combine like terms if we have terms that can combine on either the left side or the right side. If you have variables on both sides, you want to get the variable to one side so it's in the form of a two-step equation. Then you're going to solve the two-step equation, then the one-step equation, and then check your solution. So solve the following equations algebraically by showing all steps, then check. So in our problem, 2 times the sum of a plus 4 is equal to 3a minus 1. We have to clear away the parentheses first, so we're going to distribute. So we have 2a plus 4 is equal to, and we can change the subtraction to adding the opposite. Now we have variables on both sides. So we can get rid of either the 2a or the 3a. We're going to subtract the 3a from both sides. So we're left with negative 1a plus 4. The 3 minus 3a cancels each other out, so you're left with a negative 1. Now we're down to a two-step equation. Still want to get the a by itself, so now we're going to subtract 4 from both sides. So we're left with negative 1a is equal to, because the 4 minus 4 gives you 0. And over here, we can squeeze a plus in front of the subtraction or change it to add in the opposite to give us negative 5. Then we're going to divide both sides by negative 1. So your a is equal to a positive 5. In example 2, we have 2 times, in parentheses, 6m minus 1 is equal to 8m. The first thing we want to do is change subtraction to add in the opposite, and then we want to distribute. 2 times your 6m gives you 12m, plus 2 times the negative 1 gives you negative 2 is equal to 8m. Whenever you have a variable by itself, you always want to get rid of the one that has a number attached to it. So we're going to subtract 12m from both sides. So the 12m's cancel out, bring down our negative 2, and then over here we can change subtraction to add in the opposite. So we have 8 plus a negative 12m. So we take the sign of the larger number and subtract. Now we have a one-step equation. So we're going to divide both sides by negative 4 to get that variable by itself. On the right side, you're left with m. And then on the left side, a negative divided by a negative is a positive. And then we just have the fraction 2/4. So all we just need to do is reduce the fraction to a half. A half is also the same thing as 5/10 or 0.5. Number 3, we have 2 plus 3 times the sum of x plus 1 is equal to 6x minus 3. So we're going to start by distributing. Bring down your 2 plus your 3 times x is 3x plus 3 times 1 is 3 is equal to 6x minus 3 or 6x plus a negative 3. On the left side, we can combine like terms. We can combine the 2 with the 3. So we're left with 5 plus 3x is equal to 6x plus a negative 3. Now we have variables on both sides, so we can subtract 6x from both sides. So we are left with 5 plus, and then we can change this to add in the opposite. So we have to take the sign of the larger and subtract, so negative 3x. The 6 minus 6x cancels out to 0, so it's equal to negative 3. Now we have a two-step equation. So we're going to subtract 5 from both sides. 5 minus 5 gives you 0, so we can bring down our negative 3x equals
a negative 3 minus 5, or we can change it to plus a negative 5 to give us a negative 8.
Divide both sides by a negative 3. And we're left with x equals, and then a negative divided by a negative is a positive, and we have an improper fraction 8/3. 3 goes into 8 2 times, which is 6, with 2/3 left over. So x is equal to 2 2/3. Number 4, we have to distribute on both sides. We also have to change subtraction to add in the opposite. So it's 5 times a is 5a. Plus a negative 15, because we have to distribute the 5 to the negative 3. 3 times a is 3a, and 3 times 7 is 21. Variables on both sides, so we're going to get rid of the 3a. So we end up with 5a minus 3a is 2a, plus a negative 15. 3a's cancel out, so it's equal to 21. Now we solve the two-step equation. We're going to add 15 to both sides. So we're left with 2a is equal to 36. Divide both sides by 2, so a is equal to 18. All right, number 5 says 2 times the difference of x minus 1 is equal to 4 plus 2x. Change subtraction to add in the opposite, distribute. So we have 2x plus a negative 2 is equal to 4 plus 2x. So we have variables on both sides. So we'll subtract the 2x from both sides. But since the 2x is the same on both sides, when we subtract them, they both cancel out, and you're left with negative 2 is equal to 4. Well, that's not true. That means that no matter what you substitute in for your x, your left side will never equal the right side. So you can write null set, or you could do the circle with a line through it, or you can do the empty brackets. Most popular is just writing the word null set. On number 6, we have a negative 2 times x minus 1 in parentheses is equal to 2 minus 2x. So change subtraction to add in the opposite. Distribute, so we get negative 2x plus, this is a negative 1 over here, so we get a positive 2 is equal to 2 plus a negative 2x. Now we need to get the variable to one side, so when we add 2x to both sides,
so the negative 2x on the left and on the right cancels out when you add the 2x to both sides. You're left with 2 is equal to 2, which is all numbers. This means that no matter what you have for the value of the variable, the left side is always going to equal the right side.
So these are two different cases compared to the previous page when you didn't cancel out your variable and you ended up with one solution. That is the end of the notes on lesson 8.5.